Now, our next speaker is environmental manager of DEME. He manages in a smart way underwater noise. Sustainable management of underwater noise effects during marine works is much more than controlling critical sound levels. Only from a dedicated monitoring of the marine ecosystem and its sensitivity, operational mitigation can be successfully implemented. I would love to have your attention for Marc Huygens.
Good afternoon, and also from my part, welcome. And it's a little bit strange that a contractor has the honor to talk about environmental aspects associated with offshore wind. Nevertheless, I will try to explain to you why it is so important and why it isn't that strange that a contractor is talking about environmental management and in particular underwater noise management. So that's the reason why I start just to put it as one of the topics, as one of the environmental effects that can be associated with offshore wind projects, as you see it here on the slide. And of course, underwater noise is hot today. We're talking about a lot of things today, but underwater noise is one of the main environmental effects associated with the building, with the installation, and with even the maintenance of offshore wind farms. But let me start by just give you a smart or a small introduction about general environmental approach and the way we want to tackle environmental effects on the operational side. And as you see, there are three steps to be taken. And the first step to be taken is avoidance. The second one is minimization of the effects, and the last one is compensation. And with the examples given on the slide, you also give an idea about how to proceed, and the higher you get in the hierarchy, as pointed out here, of course, the better you can tackle the problem and the more sustainable you can tackle the problem. So that's the reason why it is important to start thinking about underwater noise, to reflect a little bit on what's really on the scheme, what's really on the table, what are really the elements that we have to manage when we're talking about underwater noise. And that's the reason why in the rest of this presentation I will just tackle two components, or the two main components, and just make a reflection on a little talk we also do with each other, today at an interdistance of 1.5 meters, but nevertheless, every talk is about the sender and is about the receiver. And these are the main aspects I want to run through, talking about underwater noise also, because a talk is also a little bit creating noise, of course. So that's the reason why we just start on what are the sender aspects that we take into account. In other words, what are really the sources where the underwater noise is generated, talking about working in marine environment. And as you see here on the list, it's not only about pile driving, but it's also about drilling and blasting. It's also about dredging. It's also about placement of dredged material in disposal areas. So it's really important to notice that we are not only talking about driving of piles, we're not only talking about drilling of material, but we also talk about other aspects. Next to that, it's also important to know what kind of receivers we have on the board here today. And I will not run into detail because I'm not an ecologist and I'm not a biologist, so I don't know the details about all this. But nevertheless, what I've heard and what I've learned in the last couple of years is there's a whole bunch of sensitive receptors in the area over there. In the oceans over there are living quite a lot of animals that are interfering with this underwater noise and with this generation of underwater noise. And they all have their own auditory bandwidths, as mentioned here. So it means that we should know what kind of sensitive receptors, what kind of animals, what kind of species are living in the ocean that we are working in. And without running into detail, I just give you a flavor about different aspects that can be associated on the sensitivity of these receptors. So it's really very important to know about their vulnerability and to know what is their behavior, not only on the individual scale, but also on the population level, for instance, because talking about one individual species, that's nice, that's good, but also to learn about what is the populational behavior of, for instance, dolphins or seals in the ecosystem we are working in. That is related to the direct impact on survival rates, but also the indirect behavioral disturbances is very important. And without running into detail, also the auditory masking, for instance, is a very important aspect. As you see, there's quite a lot of ecological and biological aspects and even challenges to be tackled in the forthcoming years, because we don't know that much about this kind of aspects. So this is one of the first steps I want to stress on. It's really important to know what kind of sensitive receptors we are confronted with, we are working together with in the ecosystem in order to develop an offshore wind farm. So it's really important to have that, to keep that aspect as the first pillar, let's say, in this line of story, let's say. The second line is indeed then on the technical side, and that's perhaps the most interesting part for you as the audience, but nevertheless, I think it's also important to notice the first line on this underwater noise management development. So let's run a little bit into detail what kind of technical aspects, what kind of technical tools, what kind of technical instruments we have available, we have on our site, just to make a proper underwater noise management. And these three topics as mentioned on this slide here are quite straightforward. We're talking about avoiding ecosystem periods, we're talking about ramp up and shut down methodologies, method statements, and we're talking about using acoustic devices just to keep away the mammals or just to keep away the species from the work. Other kind of mitigation techniques, without again running into detail, we're talking about bubble curtains, we're talking about adapted hammering systems, we're talking about hydro sound dampers. And there are quite a lot of studies going on the technical behavior, on the technical specs of these mitigation techniques. And without going into a discussion about whether or not the lowering of the underwater noise is about 10 or 15 dB, decibels, it's not about that, it's about having a kind of series of mitigation techniques available just to handle and to manage the underwater noise level. Next to the mitigation techniques itself, we can talk about indeed adapted hammering systems, but we can also talk about alternative foundation installations. So it's really important to have also this kind of alternatives in place, just to be sure that we can have noiseless installation or as noiseless as possible installations in place. And the ultimate noiseless installation is, of course, if you don't have to pile, if you don't have to drill into the sea bottom, if you create a kind of floating construction, and then we're talking about, of course, offshore wind in a floating device. Now, what are the steps to the future, taking into account indeed these two pillars? I think it's really important to have a kind of European level approach on this management system. And let's try to harmonize and let's try to come to a uniform procedure, to a new uniform permitting, to even a uniform monitoring program, just to have a good view on the noise management. And what are the challenges and what are indeed the needs that come up within the next coming years? Because indeed offshore wind is still developing and we are always working with bigger installations, with bigger piles, with bigger hammers. And of course, the challenges that are associated with that will have an impact on underwater noise. But next to that, there is also, of course, the very busy business, let's say, on developing offshore wind farms. And just to indicate, you see the plan of the North Sea, not only in front of the Belgian coast, but also on the Dutch and on the UK and on the French coast. There's a lot of activities going on and there's a lot of offshore wind farms going on. So we are not talking about any longer about any individual project anymore, but we should also see what is the cumulative and what is the transboundary effect of all these offshore wind farms, not only on the underwater noise, but in particularly on the underwater noise, just because the ocean is, of course, transboundary and cumulative as itself, let's say. So business planning and project planning will become quite crucial today. Now, let me finish by just putting this kind of steps to the future on the desk, in a sense that we should go for a proactive and adaptive technical management. So, in a sense that we should, on the technical level, try to find out and try to develop the new innovations and have a combined approach of different techniques tackling for the optimum diminishing of the underwater noise impact. But next to that, next to the technical side, indeed, we also need a very fundamental biological understanding of the vulnerability of the sensitive centers, which is really important. And I like to finish to show you two potential, let's say, instruments to tackle these monitoring devices. One of the things is that we are using quite recently this kind of unmanned service vehicles just to record the underwater noise in a very dynamic and in a very proactive way to see what's happening during the piling, because you can imagine that the circumstances and the whole, let's say, setup of the configuration is quite critical to have a good view on the underwater noise. And finally, I like to show this picture because that's a quite recent publication on the assistance of drones from the operational environmental monitoring, in particular also on the underwater noise. And I like to share this final comment with you, saying that we should look for the integrated opportunities. Perhaps we should tackle the risks in a common place, but we also take a shared benefit of all this kind of adaptive operational management system. Thank you.
Thank you. Someone wonders, what is the most important step to be taken in order to realize that integrated approach as presented?
Yeah, well, the most essential step to be taken is bring all parties around the table, I think. Yeah. This is really important. And it seems very straightforward and very easy to do, but it isn't. Try to understand an ecological specialist and bring them together with an economist and a technical engineer around the table and try to find a kind of common understanding. It's really challenging. And that's really the basic step to be taken. We have done this for another or for several other environmental aspects. So perhaps this can inspire us also for the underwater noise management.
Yes, connecting these different views and positions.
Indeed.
That's for the future. Thank you.
Thank you.